Hi everyone, this is Babak Kianian, the corresponding author for this work from Lund University in southern part of Sweden. I'm going to summarize our ongoing quantitative analysis in the form of case study on behalf of my co-authors. The transport sector is responsible for nearly 30% of EU total CO2 emission, of which predominantly 72% come from road transportation. As part of an effort to reduce CO2 emission, the EU has set a goal of reducing emissions from transport by 60% by 2050 compared to 1990 levels. The right pictures in this slide show the EU Green Deal, which is a proposal for a law, as you may see in this slide, and a few more coming up. It is kind of a pressure cooker environment for the automotive industry. The transportation industry landscape is going through a massive transformation due to trends such as autonomous and electrified vehicles. In case of electrified vehicles, internal combustion engine would most likely be the prominent power source in motor vehicles until 2030. However, advancement, adoption, and deployment of hybrid and electric vehicles seems to be much faster. There's also a significant social pressure in industry to be held account on the new strict air pollution standards, particularly the automotive industry due to scandals in recent years over vehicle emissions. As a result, there are many movements from market-leading car manufacturing, for example Mercedes-Benz, to move towards CO2 neutral production from 2022. New modern power and drivetrain need to be designed and manufactured based on the raising automaker requirements like higher performance. Meanwhile, costs must be minimized in order to obtain or secure market competitiveness. In fact, a company must meet its financial target to realize the sustainability of the company in the first place. Now, let's take a look at the situation in Sweden. If you zoom in the manufacturing industry specifically, you can see that the automotive sector employs the most number of people and thus deeply embedded in the Swedish society. On a side note, 20% of global production of powertrain and drivetrain transmission parts like gears are produced in Sweden. You heard it correctly. It is 20%. That shows the importance of this sector. And I'm emphasizing on this, as most of the R&D and innovation are on the batteries and storage development sides. In case of internal combustion engine, gearboxes are needed. In case of electric vehicles, e-motors like planetary gears are needed. So there is a high demand for gear production. Now if you look at the financial situation in Sweden, Swedish GDP rose by 0.1% in the second quarter in seasonally adjusted figures. This is the same trend as the previous quarter. The outcome reinforces the image of the slowdown in the Swedish economy. GDP growth during the first half of 2019 is the weakest since the crisis year 2009. Economic activities has a slowdown in Europe as well. In the EU28, GDP rose by 0.2% during the second quarter of 2019, with the European largest economy, Germany, a slowdown development. Sustainability has been shown to be a wicked problem. This means that the systems on which we rely are deeply connected and interdependent. This is often leads to unintended consequences and rebound effects when working towards sustainability. With the current IPCC report dictating the need to stick to 1.5-degree target, there is a need for a radical shift, especially with the manufacturing industry. Otherwise, the current practices only could lead to small and slow incremental changes like less bad practices. An example of unintended consequences from greening manufacturing is as follows. From the designer perspective, when they did their best to reduce, for example, the fuel consumption, but that led to the car owner to drive more as it cost them less, thus increase the in-use car carbon emission. Even if the car owner didn't drive more, there's actually an indirect carbon increase as the fuel saving for the user gives them more disposable income, which they then may choose to spend on high carbon activities like flying. Thus, The efficiency gain are normally eaten up by continued economic growth and the rebound effect. The objective of this study is to make an evaluation of how effective carbon policies are depending on how they are influenced at company level. The following are some of the carbon policies we will include in our paper analysis. Cap and trade scheme, carbon tax, science-based targets, and internal carbon pricing. For a deeper understanding of advantages and disadvantages of each and every of these approaches, I would like to refer you to our article literature review section related to carbon policies. As you can see in the picture on the right side, the planetary boundaries shows 9 boundaries which are the essential life support system. We have already passed 4 of these 9 tipping points as global society, being climate change, loss of biosphere integrity, land system change, and altered biochemical cycles. The Planetary Boundaries by Earth Scientists is urging organizations and decision makers the importance of respective environmental damages. Ever since the Brundtland report, the decoupling has been seen as the solution to address environmental and resource constraint. Relative decoupling is happening, but absolute decoupling is far away. These researchers utilize the following tools: the Absolute Environmental Sustainability Assessment Method, which is comprising of 4 assessment steps and 6 methodological choices. Thick borders in the picture on the right side indicates that an element is a unique to this method, as opposed to take part in all quantitative sustainability method like LCA. In addition to this, we use ISO 14008, which provide a framework that includes principles, requirement, guidance for monetary evaluation of environmental impact and related environmental aspects, following the principle of welfare economic. And in addition to this, we use Bankstein recent book is 2020 book, which is behind environmental priority strategies. We are currently using these methods, models, and data in addition to the cost model, which I will go through in the next slide. Of course, detail of this is fully written in the manuscript. As we have seen before, we must decouple economic growth from increased emissions. Thus, we need a comprehensive cost model. This paper utilized a microeconomic cost modeling approach called performance part costing, with a breakdown approach variables, avoiding the aggregated macro models popular in the automotive industry. This cost model will be updated to include variables related to the environmental impact and also CO2, and will be utilized to evaluate both the current and probable future costs of doing business. In doing so, the usual side effects like impact burden shifting and rebound effect need to be closely monitored and considered from the very beginning. The departure part from this study is a nested dependency model where the economy is fully owned subsidiary of a society and the environment. This is how we have retrieved the required data for analysis. 6 companies, 11 individuals interviewed between the years 2016 and 2018, and the role within the interviewees were from equipment operator to process and production engineer up to C-suites being CFO and CEOs. Acknowledging the entire value chain impact and also the interlinkages among different systems, we had to narrow this case study scope to cradle to grade, as you can see in the right pictures illustrating the selector processing route. We have developed a detailed manufacturing cost model as I described in the previous slide for each and every production step utilized for this gear wheel and calculate the manufacturing cost per fabricated part. With the help of scenario optimization, each cost driver can be simulated to analyze different cost scenarios. Only the following process routes are analyzed from cradle to grade assessment. The scope is due to the accessibility to data issues and partner companies' available equipment. This is a dashboard page that we have developed for this case study gear wheels, and for each production step showed in the last slide, there's a separate sheet for scenario planning and detailed variables of each cost driver and how they can be optimized. Regarding the optimal result, we use optimization approach to find better solution. So the objective function is formulated in a way that it returns the intended key performance indicators such as cost that you can see in the y-axis and environmental impact in the x-axis. However, a major issue here is the intention of optimizing two objectives that are mostly in conflict. In such situation, it is not always very easy to find a single optimal solution that maximizes all the conflicting objectives simultaneously. Rather, there is always a set of alternatives, which are actually Pareto optimal solutions. Thus, none of the objective can be improved unless another objective is degraded. Therefore, the results are near optimal solution, probably good enough rather than the global optimum. To conclude, CO2 is approximately contributing to 75% of overall warming effect when evaluated in a 100-year time frame. Given its importance in climate change, it is the focus of this case study. Upon further operationalization of other planetary boundaries limit, this structure analysis approach can be replicated for other planetary boundary life support system variables. The intended outcome of this research study is to quantify and assess multiple scenarios for case study companies, whereas the variable of carbon policy costs and production costs can be altered and compared with a potential environmental impact in order to have a better understanding of the impact on the company profit and possible rebound environmental impact. These scenarios can enable wiser carbon policy design and implementation from our perspective to pave the path to practical progress needed to reach the 1.5 degrees Celsius target. Our initial data analysis point out toward a financial challenge for companies in a progressive carbon policy cost is in place. The planned discussion is around the potential trades-off of enacting a stringent carbon policy cost, which would require radical change within the sector versus more incremental carbon policies, which still give a space for a sweet spot between a company profit level and environmental impact. Many thanks for your attention and listening. I would like to get feedback through emails or live chat via Zoom. Bye bye.